Hi, I'm Mr. Ray, and what I want to show you guys today is how to better visualize and understand Pythagorean Theorem. So a lot of us already know the Pythagorean Theorem. It's going to be a squared plus b squared equals c squared. All right, and you may know how to use this formula really well. Today, the main goal is to show you what it looks like and why the formula works, and just really visualize it better. So a squared plus b squared equals c squared. We're going to go ahead and draw an example. All right, and we're going to put our right triangle square that designates that this is a right triangle. Okay, and the first thing we need to do is designate which sides A, B, and C. Okay, so one of our legs is going to be A, one of our legs is going to be B, all right, and the hypotenuse is always C. Okay. All right. I myself like to make the shorter legs A, the longer legs B. That just makes it easier for me in the long term to remember it and keep it all straight. All right, so I'm going to put some numbers here, okay, for the purposes of the example. Okay, and I'm going to say that leg A is going to be 3, leg B is going to be 4. All right, and we're going to make our hypotenuse a question mark. So that's what we're trying to find. All right. And again, you may know how to do this with the formula already. My goal today is to show you the picture form and what it really means when we say a squared plus b squared equals c squared. So the word squared there is really important. So first, I want you to go over to leg A. All right, and we already know that this is 3. Okay, and we're going to square it. And I don't want you to just square it. I mean, 3 times 3 is 9. I want you to actually draw it. So we're going to draw the square of 3. All right, so pretend it's a square. So we have 3, 3, and 3. Now, if we want to know the area of that square, 3 times 3 is 9. And I'm going to draw the grid just to visualize that as well. So we have 9 area for the square of side A. All right, we're going to do the same thing over here on side B. Okay, so we're going to draw our square. All right, we're going to put every side as 4. All right, lift it up there for you. Okay, and we're going to make our grid again. All right, and this shows us that the area of the square of side B is 16. Okay, so we're going to take this theorem and we're going to transfer over here real fast. We're going to write it again, but this time we're going to put in these values for the squares. All right, so we've got 9 plus 16 equals something, right? C squared, that's our question mark. Okay, so now we're going to go back to our picture here. So what we've basically done so far is that we've shown that the square of side A squared, is 9, the square of side B, B squared is 16, and those things added together are going to equal C squared. Okay? So let's just go ahead and draw a square first over here. All right, now this plus this equals this. That's what we're working on. But what we don't know is this side yet. Okay, so we can kind of figure out that if we do 9 plus 16 and we put it together, like the formula says, right, we're going to get 25. And that's going to be the area of this. Okay. Now, you may recall that finding the side of a square when you have the area requires what's called a square root function. All right, so we're going to take the square root of this, and what that's going to give us is what times itself equals 25. So 5 times 5 equals 25, all right, meaning that each side of that square is 5. So I'm going to go back here. I'm going to put that each side of this square is 5, and that gives us the length of our hypotenuse. So 5 times 5 is 25, and that means that the hypotenuse length, or just this part of this triangle, also must be 5. Okay, so let's do a quick recap. All right, now what we've done here is we showed the theorem, which is a squared plus b squared equals c squared. Okay, we showed the math, right? We showed that 9 plus 16 equals 25. Okay, and then the last thing we did, or the most important thing we did, was we visualized it. We showed the picture. All right, and so we had 9, a square of 9, plus a little bigger square of 16 equaled the larger hypotenuse square of 25, the square root of which was 5, finding us our hypotenuse. Thank you.